In this video, we're going to be focusing on determining how many significant figures you have in a value, as well as how to calculate using significant figures. So when I talk to students about significant figures, the most common questions I get are, what are significant figures and why do we care? Well, in order to understand why it is that we as scientists care about significant figures, we first must differentiate between exact values and measured values. So take this apple, for instance. This is one apple. It's exactly one apple. It's not 0.99 apples. It's not 1.002 apples. It is 1.00000 with an infinite number of significant figures apple. This is an exact value. Now, if I were to cut this apple in half, in order to determine how well or how precisely I cut this apple in exactly one half, I would have to do a measurement. One way that I can measure how good I was at cutting the apple in half would be to weigh the apple whole, cut it in half, and then weigh one of the halves. So one tool that I could use to weigh the apple might be your typical bathroom scale. So this is a scale that you might have in your own dorm. That can weigh pounds up to 1/10 of a pound typically. So if I weighed my whole apple on the bathroom scale, let's see, so the whole apple, it might weigh somewhere around 0.3 pounds. When I cut the apple in half and weigh one of the halves, it might weigh 0.1 pounds. If I compare 0.1 pounds to 0.3 pound in order to determine the percent of the apple that the one half is, I end up with about 33.33%. Doesn't seem I was very good at cutting that apple in half in terms of the bathroom scale values, is it? The bathroom gives us one sig fig with the 0.3, 0.1. Now, if I use an analytical balance that you might have in your Gen Chem lab, these can typically weigh grams up to the 100th of a gram. So when I weigh the whole apple, I might end up with a weight of 103.25 grams, giving me 5 significant figures. When I cut the apple in half and weigh one of the halves, I end up with 53.24 grams. Again, now I have 4 sig figs. When I compare 53.24 to 103.25, in order to get a percentage, I calculate that I have 50.69% of the apple. That's much closer to one half of the apple as determined by the analytical balance than was the bathroom. The difference here is that I had much more confidence or more significant figures in my values using the analytical balance compared to the bathroom scale. So now that we know the difference between exact values and measured values, how do we determine that this is 5 sig figs or 4 sig figs compared to the 1 sig fig of the bathroom scale? Well, there are some rules that we can follow. So to determine the number of significant figures a measured value has, you only need to follow these rules. First, all non-zero digits are significant. For instance, the value 1.234 grams has 1, 2, 3, 4 significant figures. Additionally, the value 1, 2, 3, 5 centimeters also has 4 significant figures. Rule number 2, all zeros between digits are significant. For instance, 102.3 grams has 4 significant figures, or 1.0056 milliliters has 1, 2, 3, 4, 5 significant figures. Another rule, all zeros before a non-zero digit are not significant. So for instance, 0.0006 milliliters has one significant figure, or the value 0.0123 centimeters has 1, 2, 3 significant figures. Again, these non-zeros and these zeros are not significant. Now our last rule, all zeros after a non-zero digit are significant. So for instance, 1,000 liters has 1, 2, 3, 4 significant figures. And 1.002 centimeters also has 4 significant figures. Okay, so now that you know these rules, let's practice. So in the following questions, I want you to tell me how many significant figures are in the given measured value. So now that we know how to determine the number of significant figures a given measured value has, how do we calculate with significant figures and determine how many significant figures our answer should have? Again, we have some simple rules that we can follow in order to help us determine this. 1, when adding or subtracting with measured values, the answer should have the same decimal place as the smallest decimal place value. So for instance, if we had 1.000 grams plus 0.2 grams plus 0.045 or 54 grams, right? The whole answer would be 1.254 grams. However, the 0.2 grams has the smallest decimal place. So we need to round our value to 1.2 grams, or if you round up, it would be 1.3 grams. Either way, we end up with 2 significant figures. Okay? When we are multiplying or dividing with measured values, then we use the value with the smallest number of sig figs. So in this case, we go by the sig figs, not the decimal place. So if we multiply 1.002 centimeters times 0.0005 centimeters, we end up with a value that's 0.000503 centimeters squared. Now, 1.002 centimeters has 1, 2, 3, 4 sig figs. This value only has 1 sig fig. So our answer, therefore, must be rounded to 1 sig fig, or 0.0005 centimeters squared. All right, so now let's practice a little bit with these numbers. I will give you some questions that ask you to either add, divide, subtract, or multiply various measured values, and based on these rules and the rules in determining the number of significant figures, calculate the answer to the correct number of significant figures. So now that you have a better understanding of how to determine the number of significant figures a given measured value has, as well as how to calculate using significant figures, why don't you rewind and go back to my apple example and see if you can catch the mistake that I made earlier. Okay? Well, I hope you have a very significant day.